Okay, we're going to continue with binomial model examples, trying to find out if we're going to see the binomial CDF at all in these ones. So let's read the next example. Example 6, it says 10 customers enter a clothing store. So remember that the whole number provided is usually Rn, right? And then past experience has shown that approximately 30% of people entering the store make a purchase. So that's most likely the probability given is our P. So this means that we're looking at a binomial model where n is 10 and the probability of success is 0.3. And then we're asked, what is the probability exactly 6 of the 10 make a purchase? So this is familiar language from the previous problem. Exactly 6 is still using the binomial PDF. So let's practice that. Binomial PDF. There are 10 people, 30% chance they'll make a purchase, and we want to know if exactly 6 of them will go ahead and do that. So we want to go right now to our calculator. And remember in the video for the notes, I said to hit second bars, and this is just a reminder of what we did in the previous problem, and then arrow up or arrow down, whichever one you like the best, going far enough to find the binomial PDF and CDF, and then we're looking for whether or not you have an older or newer calculator. If you have a newer calculator, they're going to give you prompts and say like the trials and what is N and what is N, what is P, and what is K, but they use the letter X. But if we have an older calculator, then it's going to be entered exactly like I wrote, and we enter it and we get our answer 0.0368. Now this one says, what is the probability at least one customer makes a purchase? Assuming you watched the last video, we know that at least 1 is equivalent to 1 minus the probability of none. So here we can do this all in one step. Since last time we knew this, we can now say none is the same. That was terrible. None is the same as the binomial PDF with 0 successes. So that's 10 people, 0.3 chance they'll buy something, but no successes. And if we do this one, we get 0.9718. And you can actually type this all in 1 minus and then hit second bars, and the binomial PDF will pop up right after the 1 minus. And you should get the same answer as me. All right, new language we've never seen. What is the probability that, and here we go, 8 or fewer make a purchase? So if you remember in my notes, when we had K or fewer successes, we used the binomial CDF, and I am struggling. N, comma, P, comma, K. And then this includes K, right? So it takes the probability of K and it adds like, let's say we're going to do 8 or fewer. So it would do like 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0 all the way down to the end. And so if we want 8 or fewer, then we can actually just go right to the binomial CDF. 10 people entered the store, 30% chance they'll purchase, and if we put 8 here, it'll do 8 plus 7 plus 6 plus 5 all the way down to 0 and add them all up. Just make sure that when you go to your calculator, since we've not done this one before, you actually select the CDF and not the PDF. And then this is another tricky one. Between 4 and 8, I'm going to make a little chart over here on the right because people say they like my chart. So I'm going to make this. It looks like this. So I list out 4 through 8, and between 4 and 8 is these numbers right here. So the trick here is to use the CDF to your advantage. So what we're going to do is we want to take all the numbers at first. So we're going to take the probability that we have 7 or below, which is the CDF at 7. Then we're going to take away all the stuff we do not want, right? So we want to get rid of 4, 3, 2, 1, 0, right? We want to cut it all out. So we're going to subtract the CDF at 4. So the way this looks is the binomial CDF, and then we start 10, 0.3, and 7, and then end those parentheses and hit minus, and then do another binom. So go right to second bars, and we can do another binom CDF 10.3, and this time we're going to take away 4, 3, 2, 1, and 0, and we will be left with 5 plus 6 plus 7. So the only probabilities that we want. And I got this as my final answer. I will do another, I'm going to do like 3 binom example videos, so I should do another between for you in a minute here. Here we've got, suppose 20% of all college students smoke cigarettes. So right here, that's our P. And then we have 15 that are selected at random. So they just gave us that this is a binom with 15 people. Let's try that again. 15 people, and the probability one of them smokes is 0.2. So this says, what is the probability that 10 smoke? And there's no like exactly or fewer than, but if you read that carefully, there's no exactly, but it is saying exactly 10. So this is the binom PDF, because it's definitely not saying more or less. So we want to think about that as the PDF at 10. So that's, 15 people, 20% chance that they smoke, and we were talking about 10 of them doing that. So this probability is like very, very small. It's 0.0001. And then we're almost done with this one. What is the probability that, and then this language, at most. So let's rewrite that to help us out. At most 12 is the same thing as 12 or fewer. So here we can actually use, if you think about it, a CDF, right? Because if it's, Dex, calm down. If it's 12 or fewer, it's okay. Go deal with it somewhere else. Then we want to talk about 12 or 11 or 10 all the way down to 0. So we would do 15, 0.3, and we put 12 as the final answer, and it will add them all up for us. And this answer is so big that it rounds to 1. And then I added this question in for practice because we always forget about the mean and standard deviation for the binom. So the mean, I take n and I multiply by p, which in this case is 15 times 0.2, or 3 students. For the standard deviation, if you remember from the notes, I have to do n times p times q. In my previous video, I talked about how to find q. We take 1 and we subtract p from it. So if p is 0.2, then q is 0.8. They actually have to, they're complementary and they sum to 1. And this is actually approximately 1.5492 students. And that's that for that page. I'm going to follow up with one more binomial video just to give you guys a few extra examples.